All right, so here's how we actually do this. So this is a table here. So, right, so I've got columns going like this. All right, and I have a starting point. My starting point is 0, 2. That's my first xy. All right, now I calculate dy dx for the point that I have here. My dy dx is negative 2x over y. Negative 2 times 0 over 2 is 0. All right, I'll go ahead and write that. Negative 2 times 0 over 2, it's 0. All right, delta x. My delta x, I'm going to use 0.2. So we're going to use 0.2 for the delta x all the way down. All right, it's all going to be 0.2. All right. For this problem, because that's what I decided. In your problems, you might be told what delta x to use. All right, now what's delta y going to be? Well, delta y is dy dx times delta x. So I'm going to go the 0 times the 0, the 0 times the 0.2, and I'm going to get 0. All right, and then I'm going to take my original x, I'm going to add delta x to it. So 0 plus 0.2 is 0.2. And I'm going to take my original y and add delta y to it. So 2 plus 0 is equal to 2. So that's my next point, 0.22. All right, that's my next point, 0.22. All right, and then I just keep doing that. You can see it lends itself really to a computer. So for this one, I'm going to have negative 2 times 0.2. So that's going to be negative 0.4 over my y coordinate, which is still 2. So I have negative 0.2. My delta x is still 0.2. It's going to be 0.2 for all time. My delta y, I'm going to have now, delta y is going to be dy dx times delta x. So this number times this number gives me negative 0.04. So I guess I'll write that. Negative 0.2 times 0.2 equals negative 0.4. All right, and then I add my delta x to my original x. So I'm going to get 0.2 plus 0.2 is 0.4. And you're going to see your x's, of course, just go 0.2, 0.4, 0.6, 0.8, etc. All right, so that's a 0.4 there, right there. And then for my new y, I'm going to go my original y, which is 2, plus my delta y, which was negative 0.4. So 2 plus negative 0.4 is 1.96. That's my next point. And I'd bring it down and do it again. 0.4 comma 1.96. Now I'm going to have to do negative 2 times x. So 2 times 0.4 is 0.8 over my y coordinate now is 1.96. Okay, this turns out to be negative 0.41. Use your calculator. Figure out some nifty program to use something. You can use technology to do this. It's nice to at least see it at least once. And you might have to do like maybe 2 or 3 iterations by hand on the AP exam. Now I'm going to do delta y is dy dx times delta x. So I have to go 0.41. So my negative 0.41 times my 0.2 is equal to, I rounded off to negative 0.08. I rounded all these to 2 decimal points because I'm going to graph them. All right, and then I get 0.6, 1.88. All right, and I keep doing that. How far do I keep doing that? Well, typically what the question is going to be is find f of 1. So I need to keep going until my x gets up to 1, right? So find the value of the function when x equals 1. I'll keep going until I get 1, see what is the y coordinate that goes with that, and then I'm done. All right? I went ahead and did all these up to 1.8, all right? And I got them right here. So you can take a nice stilly of that if you want. That's what I got. I went all the way up to 1.8. All right, you can ignore all this junk down here and all the scribblies up there. These are the numbers. I didn't want to write them over again because they're actually pretty clear. All right, so I got all those numbers. Now, so what? So I can find out, for example, that I got it down to the 0.1, 1.57. So 0.6, 0.8, 1, 1.57. So I can say things like, whatever this function is, I know that, I'm not sure if I want to write in here or not. I guess I'll write over here. I know that y of 1 is approximately equal to 1.57. All right, so given my initial condition, notice I haven't even found a solution to the equation, all right, because you might not be able to. So if I have a differential equation that I couldn't solve, when I have the differential equation in a particular condition, I know what the value of the function is at x equals 0. I can still find out what the value of the function is at x equals 1, even though I don't know what the function is, by going through this iterative method and finding out that y of 1 equals 1.57. Okay, but we can also do some neater stuff with this, which we'll see in the next video.